Coming to the next lecture in this series, what we will be discussing will be about the active and the passive elements in the electrical circuit. What we had discussed in the first lecture was about the active elements and the passive elements in the electrical circuit. Then we discussed about the inductor, the capacitor, and the resistor, the different elements which are the passive elements of the inductive circuit in detail. Then we saw about the Kirchhoff's current law and the voltage law. Whenever you are talking about electrical circuits and solving electrical circuits, most of the objects in the electrical circuit, specifically speaking in the case of the DC circuit, we are talking only about the case of resistance. So the resistance would be mostly connected in the circuit. Even the voltage sources can be connected in the series or in the parallel. So the first kind of connection in which the different passive elements like the resistors can be connected is in series. When you are talking about the series connection, the end nodes or the end points of each of the resistance will be connected together, and whenever they are connected in series, the current flowing through all the resistance will be always same, and V will be the supply voltage. There will be different voltage drops like V1, V2, V3 happening across each of these resistance, and from the Ohm's law we know that V is equal to I into R. So as the resistance is high, the voltage drop will be always high, so it will be like V1, V2, V3. And again, if you are applying the KVL, that is Kirchhoff's voltage law, to this circuit, then it is seen that the V equal to IR1 plus IR2 plus IR3, that is current through all the resistance is same. At the same time, the resistance are different, and it can be simplified as I is equal to R1 plus R2 plus R3, and R equivalent is the equivalent resistance of the circuit. Again, there is the other kind of circuit. This circuit is known as the series circuit. Again, there is the other kind of circuit which is known as the parallel circuit. In parallel circuit, the different resistance are connected in parallel, and in parallel connection, the supply voltage, if you are connecting the same circuit in parallel, then the supply voltage will remain the same, or the supply voltage can be shown as a V here across the resistance connected in parallel, and I is a current which is originating out of the supply voltage. And when the current will come through to the node, so this is a node which is used to connect all the resistance in parallel. So the current will distribute itself among each of the nodes like I1, I2 and I3, and the distribution will happen in proportion to the resistance. As said, V is equal to I into R. So now we are talking about the current, so I equal to V by, it will be V by R. So saying here, the as the resistance will be different, the current will be different for all the different resistance, and applying the Kirchhoff's current law here. So in the series case we applied the Kirchhoff's voltage law, and now we are applying the Kirchhoff's current law. We seen that at this junction the current coming in is I, and at the same time the current leaving out of the junction is I1, I2, I3. So again, the current coming will be always equal to the current which is leaving. So based on that you can solve this equation, and this equation can be simplified as I is equal to V upon 1 upon R1 plus 1 upon R2 plus 1 upon R3, and this can be written as V upon R equivalent here. And so again, the I equal to V divided by R equivalent can be solved for this circuit. So that's all about what we have seen, is that it is possible to arrange the circuit as a series circuit or as a parallel circuit. And again, we have seen how the Kirchhoff's current law and the Kirchhoff's voltage law can be applied to solve the circuits in the series and the parallel. So that's all. If you like this video, please do subscribe, and in the coming videos we will discuss about the different network theorems.